welcome to this week's problems. Now the first one we've got is about number sequences. Now as always with a number sequence we need to work out what's happening as we go from left to right. Now we know that they're increasing by the same amount each time. We look at the 1, how do we get from 1 to 1 5/8? Well, we obviously add 5/8. So every time we're going up we must be adding 5/8. I'm going to start with what I think will be the easiest one, which is the one on the right, because we're going and we're adding, and it's often easier to add a fraction or any other number in a number sequence. So we've got 2 1/4, but my other fraction is in eighths, so I'm going to convert 2 1/4 into eighths. Now the 2 whole can stay as it is, the 1/4 is going to be converted into eighths, and I know that 4 times 2 makes 8, so I also have to do the same to the numerator on top, so it's going to be 2/8. So I'm going to have 2 2/8. Now I can write that there if I wanted to. 2 2/8 might help me. Now I've got to add 5/8 to 2 2/8. So 2 2/8 add 5/8. So if I look at my fractions that I've got 2/8 and 5/8. I'm still going to be under 8/8, which is 1 whole, so I'm not going to have to change that too. So 2 2/8 is going to equal 2 7/8. Now we're going to look at the other side now, where we've got 1 whole. Now, because here I convert it to eighths, I've got eighths here, I've got eighths here, I've got eighths here, and eighths here. I'm going to take 1 whole and turn it into 8/8. And because I'm working the other way in the number sequence now, instead of adding 5/8, I'm going to take away 5/8. So 8/8, take away 5/8 will give me 3/8. Right, the next problem. Each diagram below is divided into equal sections. Shade 3/4 of each diagram. Because 3/4 is written in numbers, in words rather, I'm going to write it in numbers, 3/4, which means 3 out of 4. The first one's fairly easy because there's 4 sections, so I'm going to shade in 3 of the 4. Okay. Now this one, the second one, is different because we haven't got 4 sections. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Got 12 sections. I'm still going to shade in 3/4, but I need to work out how many out of 12 that is. So 3/4 is how many out of 12. So 4 times 3 is 12. So 3 times 3 is 9. I need to shade in 9 of those. It doesn't matter which 9 at all. Next one, do the same thing. I count up. I've got 8 sections this time. So now I'm going to have to convert my 3/4 into eighths. So 4 times 2 is 8. 3 times 2 is 6. So 3/4 is the same as 6/8. I need to convert. I've done my conversion rather, I need to now shade in 6 out of 8. Alright, next problem. Write the missing fraction. I've got 1/3 add 1/4 add something equals 1 whole. So I can use my part whole bar model to help me understand this. I've got my whole, which is 1, and I've got a third, which should be about that much. I've got a 1/4, and I've got something. So I've got a third, and a 1/4, and something equals 1 whole. Now my bar model's not been drawn accurately there, but it gives you the idea of 2 parts and a third part making the whole. Now what I need is my denominators to be the same, but I can't convert thirds into quarters because 3 doesn't multiply by anything to make 4, not a whole number anyway. So I'm going to have to convert them both into the same denominator. Easiest way to do that is to look at them and think what is a common multiple of both of them. Easiest way to find common multiple sometimes is to do 3 times by 4, or the 2 denominators together, and that will find a common multiple. So 3 times 4 equals 12. So 12 is a common multiple. I can convert them both into 12ths. So 1/3. 3 times 4 is 12. So 1 times 4 is 4/12. So I can substitute 1/3 for 4/12. And 1/4. I need to do 1/4 into 12ths. So 4 times 3 is 12. 1 times 3 is 3. So now I've got 3/12. Now I'm adding a third part. So I know these two parts together would be 7/12, because 4/12 has 3/12. 7/12. So what's the missing part? We should know that 1 whole is 12/12. So 7 add what makes 12. We could see that using the diagram. If we have a little look. So we know that we have got 12ths, so we need 12 boxes. That's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes. So 1 whole. Now because we've converted our fractions into 12ths, we've got 3/12, which is 1, 2, 3/12 was here. 3/12, and then we also had 4/12, which is 1, 2, 3, 4. So there's our 4/12. So altogether we have got 7/12. So to make 12/12, or 1 whole, you can either do 12 take away 7 equals 5. So 12/12 take away 7/12 equals 5/12. Or you can use the diagram and you can see that there are 1, 2, 3, 4, 5/12 left. And if you add all those 12ths up, you will have your whole rod 12/12 is what you started with. Right, and hopefully we can move that out of the way. And we'll have a look back at the next problem. Here is number line, what is the value of x? So a bit like last week when we had our algebra, x just stands for a missing number. Clues we've got is we've got 1 at this end, we've got 0 at this end, and we've got this one that's slightly bigger, which is the halfway point. And we should know that we have our units column, we have our decimal point, we have a tenths column and a hundredths column when we've got a number. So we've got 0, or 0.00 over here, we've got 1.00 over here. Halfway is halfway between 0 and 1. 1 equals 10 tenths. So halfway is half of that, equals 5 tenths, and 5 tenths, we put a 5 in the tenths column, so 0.5. So this number here is 0.5. Okay? Each of these intervals then is a tenth. So we've got 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. X then is 0.7. Just check, 0.8, 0.9, 1 whole. Now we've got 0.1, 0.2. This bit here is 0.3. But that's this line here. Y isn't quite halfway between 0.3 and 0.4. So it's going to be around 0.33, possibly 0.34. And it says estimate the value of y, so you've normally got a little bit of leeway. You can be 1 or 2 tenths out.